Hello everyone, welcome back to the channel. In the previous class, we discussed about container to container communication. But in today's session, we are going to discuss about another network type in the Kubernetes, which is called pod to pod communication. If you are keen on learning Kubernetes in real time, practical way, then this video is pretty much going to clear many technical hurdles for you. So basically, whenever we deploy application in Kubernetes, they always run inside a pods. And eventually, one application will need to talk to another application. That is where pod-to-pod communication comes into the picture. In this video, we will understand how one pod communicates with another pod, how IP and pod works inside the cluster, and then why direct pod IP is not reliable. And finally, this is where the Kubernetes service concept starts. So let's start step by step. Before going to discuss what is pod to pod communication. Now, obviously, in Kubernetes cluster, we don't run only one pod. We have different pods running different containers. If one container in pod 1 wants to communicate with another container in pod 2, we must use the IP address of the pod and the port number that the container is exposing. However, since every pod gets its own IP, communication happen through the pod IP colon port number. Okay, so that is where pod to pod communication starts. Now, for example, let's assume we are running two pods. One pod is running Apache, which is HTTPD, and another pod is running Nginx. Both are exposing port 80. We are creating the pod using a simple YAML files here for testing the pod-to-pod communication. So inside this YAML files, we defined kind API version. Inside spec, we simply define the container name, image, and container port. So these are the simple YAML files. At this stage, we are not creating any service. We are only exposing the port inside the pod. After creating the pod, we need to run the kubectl get pods-o wait command. Now we will be able to see the IP address of each pod. Then we are focusing on accessing pod from one pod to another pod. Once the pods are running and IPs are assigned, the communication is simple then. From anywhere inside the cluster, we can do curl space pod1 IP colon port number. Again, if you want to access pod2, you can go to the pod1. You can do curl space pod2 IP colon 80. If you hit the Nginx pod IP, then Nginx response. If you hit the Apache pod IP, Apache pod response. This is how basically one pod can communicate with the another pod using pod IP colon port number. And of course, inside the same pod, containers can directly communicate using the local host since they share the same network namespace. That is where intra-pod communication happen. So let's watch. Now this is the Nginx YAML file. So we have taken simple YAML file, and then this is the Apache YAML file. So this is also very simple for testing the pod-to-pod communication. Then kubectl apply -f nginx.yaml kubectl get parts. Now it's created and it is up and running. Then kubectl apply -f http.yaml. Then again kubectl get parts. Now see, both parts are up and running. Then kubectl get parts -o wide. Now we will able to see IP addresses of each pod. Now let's see access part. kubectl exec-it, we can give pod name, then --/bin/bash. Enter. Now we are there in the Apache 2 pod. We want to access Nginx pod. So for this, we can use curl space IP address of the Nginx colon port which is exposed. Now see, welcome to the Nginx pod. So again, you can came out from the Apache 2. You can go to the Nginx pod and then access to the Apache pod. We are going to access using curl IP address of the Apache, then port number. See here, welcome to the Apache. Okay. So this is how we can able to access the pod to pod communication. Okay. This is how basically one pod can communicate with another pod using IP colon port number. Now assume both pods are running on the same node, because here we are using Minikube, so only one node is there. So now Apache pod and Nginx pod both are running on the same worker node. Now let's see, pod to pod communication still happens using the pod IP and port which is exposed. Curl, you can give the pod IP colon 80. Now see here, same way you can give the Nginx IP colon port. So you can able to access from the worker node also. So whether the pods are running on the same worker node or different worker nodes, the communication logic remains the same. So in the Kubernetes cluster, if you have a 10 nodes, if the pods are running on second node, you can able to access those pods from any worker node. Okay. So even if you can do container to container communication and pod to pod communication, there are few challenges are there. So now this is where things start getting interesting. The first challenge is, if a pod gets deleted and new pod is created, the IP addresses changes. Okay, let's see. I'm going to delete the Apache pod. kubectl delete -f ht.ml. So now it is going to delete it. Now if you can see the kubectl get pods, we have only one pod. Now kubectl apply -f httpd.ml. Now pod got created. Now let's see here and compare the IP addresses. Now see, Apache have 10.224.0.15. Earlier it is 14. Okay. Now we are discussing the first challenge. That means if a pod gets deleted and new pod is created, the IP addresses changes. For example, pod was running with 10.224.0.14. Pod crashed or got deleted. Then in your real-time project, a replica set or deployment object recreated. So for that new pod, new IP allocated, which is 10.224.0.15. Okay. So what happened in that case? Your application IP changed. Now think more practically. You gave your pod IP to your testing team or someone testing the application. Suddenly the pod restarts, new IP comes. Now nobody knows the new IP address. So it's not easy to remember IP addresses, and eventually it becomes impossible to manage. So that is where big technical hurdles starts. And then coming to the second major challenge, what will happen? Pod IP works only inside the Kubernetes cluster. So if you try to access pod IPs from the your laptop or your office system or external server, it will not work. Why? Because pod IP is internal to the Kubernetes network. So now a user, you are parking this thought, how do I access my application from outside of the cluster? And also, how do I avoid changing IP problems of the pod? So let's assume your application is deployed and testing team says, give us the application IP. We want to test the application. You give that pod IP to the testing team. Everything works. Suddenly pod crashes or it is deleted or it's restarted. Deployment recreates the pod. Now the new IP will be assigned. Now what will user do? User cannot access anymore. And whatever it is, testing team or QA team or production team, it's not going to be easy for anyone to keep updating IP addresses. So in this case, what we need is something that does not change even when pod are recreated or reapplied. Something that we can access inside and also from the outside of the cluster based on the type. This is where Kubernetes introduced a new object called service. So in the next class, we will see using service, even if we can change the pod IP, how we can access that application. So, and then how to access the application from outside of the cluster. We will go through that actually. So in this video, we clearly understood how pod to pod communication works, how containers inside the same pod uses localhost, how different pods communicating use pod IP colon port number, why direct pod is not reliable, and this is where Kubernetes service is required. So in the next video, we will go deeper into the Kubernetes services, why Kubernetes service, what are the types of Kubernetes services are there, and understand how exactly they solve these challenges. If you found this video useful, could you please like the video, subscribe to the channel, and share it with your someone who is keen on Kubernetes learning. See you in the next video. Thank you all.